Happy Monday, guys. Today is May 4th, and this is for Math 1. Today we're going to talk about Intro to Exponentials, comparing linear to exponential functions. Now, if you remember from Chapter 5, then much of this should just be a review. Okay, so it shouldn't be brand new. We did a lot of this already in Chapter 5, talking about the difference between linear and exponential. The only difference was that we called them arithmetic sequences and geometric sequences. Now remember, sequences can only be like first term, second term, third term, fourth term, nothing in between, has to be a list of numbers, versus linear and exponential functions can be any number. Okay, so I'll show you what I mean by that in just a second, but they follow the same pattern. Okay, so let's just kind of look at some of their similarities and differences. So I'm going to do linear on this side and exponential on this side just for our first step here. So our equations, so the linear equation y equals mx plus b, that makes a line. Exponential equation, remember that curve. Remember the starting value here and then the multiplier here to the x power. Remember we did that. Okay, and so they look like this. So obviously linear looks like a line, exponential, some people call it a J curve. But it is an exponential curve. Okay, starts slow, remember, and then it jumps up quickly. Okay, linear grows by adding the same number every time, and exponential grows by multiplying the same number every time. Okay, so remember, linear, we studied them with arithmetic sequences, and with geometric sequences, we studied exponential. Okay, so I'm just going to show you kind of the difference here. So here's two tables. Okay, so if you look at the left table over here, you try to see what's happening. Notice that for the x, it's just adding 1 every time. But for the y, so to get from -1 to +1, there's two things I could do. I could either add 2 or I could multiply by -1. So I got to check it for the next one too. So to get from 1 to 3, I'm also adding 2. Okay, so my pattern here is adding 2, and from 3 to 5 is adding 2. That's what makes it linear, because it's adding the same number every time. Versus over here, again, notice the x's are going by 1s, 0, 1, 2, 3. Down here, from -1 to -3, I could be either multiplying by 3 or I could be subtracting 2. So then I got to check the next one. So from -3 to -9, I can't subtract 2, doesn't work, but I can multiply by 3. So that means I'm multiplying by 3 here, and -9 to -27 is also multiplying by 3. So since I was multiplying by the same number every time, that also means that it's exponential or geometric. Remember, exponential is talking about the type of function, specifically when we're talking about the graph and the equation. Remember, geometric's like a sequence, it's a list of numbers. Okay. One more thing I want to say really quickly before we go into some examples of this. When you're looking at these types of exponential versus linear, sometimes what you're adding or what you're multiplying won't be obvious. Remember, we talked about this in Chapter 5. Okay, so if I can't tell what I'm adding, remember the shortcut is I can subtract backwards. So 5 minus 3 gives me the 2. 3 minus 1 gives me the 2. 1 minus a -1 gives me the 2. Okay? And if I want to find out what it's multiplying by and I can't tell normally, I can divide backwards. So -27 divided by -9 is 3. -9 divided by -3 is 3. -3 divided by -1 is 3. Okay, so just a reminder about that. If you can't tell, use that shortcut to help, okay? All right, so let's look at an example here, okay? So I'm going to get away from my table up there. So we're just going to look at an example. We're going to try to figure out what kind of function this is, all right? So the first thing I'm going to do is I'm going to try to look for a pattern, okay? So from 5 to 10, I could be either adding 5 or multiplying by 2. So I got to check the next one. From 10 to 20, I can't add 5, but I could multiply by 2. So that means my pattern is multiplying by 2, which means I'll just make myself a note that I already know that this is exponential. because it's multiplying by the same number every time. So remember when we wrote our equations before, remember this? So the first one, I just have the 5. 10 is 5 times the 2, right? 20 is the previous term times the 2 again. Remember we did this? Previous term times the 2 again, and so on. But then remember we can write it in our shortened form. So remember this is 5 times 2 to the first power because there's 1 and 2. This would be 5 times 2 to the second power because there are 2 2's. This would be 5 times 2 to the third power because there's 3 2's. And remember that number up here matches with your x value. So then this one would be 5 times 2 to the fourth, 5 times 2 to the fifth, 5 times 2 to the sixth. Remember we did that in chapter 5? So then for our equation, the stuff that stays the same, the 5 times 2 is still in our equation. This is our starting value. That's what we're starting with, 5. And the multiplier is 2. And this number right here is your x value. So I'm just going to put an x right there. Okay. Obviously, exponentials have an exponent in the equation. That's why they're called exponentials. Okay. So just a reminder, in case we've forgotten, this here is the y-intercept, or the starting value, and this here is the multiplier. Okay, so just a quick reminder about that. All right, so that's that one. Okay, let's try another example. Okay, let's look at a different example here. So again, I'm going to try to see the pattern. So to get from -2 to -3 could be adding 5, or I'm not sure off the top of my head what I could multiply by, but I could divide backwards, remember? So 3 divided by -2 would give me -1.5. So it could either be adding 5 or multiplying by -1.5. So let's check the next one. 3 to 8, it's adding 5, okay? So I'm adding 5 every time here. 8 plus 5 is 13. 13 plus 5 is 18. Pattern continues, right? It's adding 5 every time. And it's going up by 1 on my x's. So remember, this is my slope. So 5x, since it's, oh, I should have written down, this is linear, right? Because it's adding the same number every time. So 5x, this is what I'm adding every time. Plus, and then my starting value, which is the 0 term right here, -2. Now, do I need to write plus and -2? No, it's kind of bulky to write both signs. So it's a little bit easier if we just write it as -2. But it's not wrong if you write it the other way. And this is linear because there's no exponent in my answer. Notice the x is a regular x. It's not an exponent. Okay? That's linear. All right? If you guys have any more questions, feel free to let me know. Contact me through Remind, Google Classroom, email, whatever I can do to help. Again, remember, if you need more help on this also, you can also look back at your notes from chapter 5. We studied a lot of this in chapter 5 as well. All right? Have a great day, guys.